Okay, so let's see how we write formulas. So we just saw that metals lose electrons, become positive, and nonmetals gain electrons to become negative, and the lost electrons go to the nonmetals and they end up attracting to each other. So one thing you're going to want to do that I don't have on here, you have your periodic table. The alkali metals, it's the first column, they form a +1 charge. So that's going to be sodium, with a lithium, sodium, potassium, rubidium, a little +1 above your periodic table. They all have one valence electron, they all lose one electron. The next row is the alkaline earth metals. It's beryllium, the beryllium, magnesium, calcium, strontium. They all have two valence electrons, so they lose 2 electrons. So they form a 2+ charge. Put that on your periodic table. Then skip the D's because they're inner electrons. Boron, at the top of boron, put a 3+. Boron and everything below it form a 3+ charge. Carbon can be a 4+ or a 4-. The column that has nitrogen, phosphorus, and arsenic, everything right there, they have 5 valence electrons, so they tend to gain 3 more, so they're a 3 negative charge. Oxygen has 6 valence electrons, it tends to gain 2 more, so they form a 2- charge. And fluorine and below, so fluorine, chlorine, bromine, they have 7 valence electrons, so they tend to gain 1 more, so put a -1 above your fluorine. Okay. When you're writing formulas for compounds, the first thing you do is you look on the periodic table, you find the symbol for each of these things, and you write down their charge. So sodium is Na, it forms a 1+ charge. Chlorine is Cl, forms a 1- charge. I got that off my periodic table that I just told you to label. Well, 1+ and 1- are balanced as they are, so the formula is just going to be NaCl. And that's because one sodium loses 1 electron to 1 chlorine. Both the sodium and the chlorine are stable. If I have magnesium oxide, magnesium is Mg2+, oxygen forms a 2-. So that means magnesium tends to lose 2 electrons, oxygen tends to gain 2 electrons. The formula is just MgO. Let's go to lithium sulfide. Lithium forms a 1+ charge, sulfide forms a 2- charge. So that means sulfur tends to take on 2 electrons, but lithium only gives up 1. You're going to need 2 lithiums to balance out that sulfur. So I'm going to say Li2s. And I know that because sulfur tends to gain 2, but lithium only loses 1, so I'm going to need a second lithium. Right? A way to cheat on these is to say if this is a 2, I'll need 2 of these. This is a 1, I'll need 1 of these. So since sulfur is a 2-, I need 2 lithiums. Since lithium is a 1+, I need 1 sulfur. So for the next one, calcium, Ca, it's a 2+ because it's in that second column. Phosphide, that's phosphorus. It has 5 valence electrons, so it's underneath the nitrogen, forms a 3-. Well, I can say I'll need 3 calciums because of this 3 over here, and I'll need 2 phosphoruses because of the 2 over there. And what happens is if I have 3 calciums and each one loses 2 electrons, 3 times 2 is 6 electrons are lost on this side. There are 2 phosphoruses and each one gains 3 electrons. 2 times 3 is 6 electrons were gained over here. So they're balanced. Let's try a couple more. Let's see. Okay, we have copper-2 oxide. So with transition metals, the metals can form different charges. Here's copper-2, here's copper-1. We never know what charge they're going to form, so we write Roman numerals to stay. This is a copper with a 2+ charge. This is a copper with a 1+ charge. Here's a manganese with a 3+, and here's a manganese with a V. The V is for 5. Manganese with a 5+. So it's the same pattern. I'm going to write the symbol off the periodic table. Copper is Cu. This 2 tells me it's a 2+, so I don't have to figure out the charge. Oxygen, it's going to gain 2 more electrons, so it's a 2-. Okay, these are balanced, right? Because this loses 2 electrons, this gains 2, CuO. Here's copper-1 oxide, so copper with a 1+ charge. Oxygen is a 2-, because I know what column it's in. So this only loses 1 electron, this tends to gain 2. I'm going to say, well, I know I'm going to need 2 coppers and 1 oxygen. And that works because if I have 2 things that lose 1 electron apiece, I'm losing 2 electrons from this side. The oxygen gains 2 electrons. Okay, so those 2 electrons went from the coppers to the 1 oxygen. So here's manganese. I look on the periodic table, it's an Mn. This 5 means it has a 5+. Oxide is oxygen. oxygen, it forms a 2 minus. Okay, so I know I'm going to need 2 manganese atoms, Mn2, and I'm going to need 5 oxygens. Okay, so that means if I have 2 of these, 2 times 5 is 10 electrons are being lost. 5 of these, 5 times 2, 10 electrons are being gained. Okay, so 10 electrons went from the manganese atoms to the oxygen atoms. Here's manganese 3 oxide, so Mn is a 3 plus. The oxygen, because it's in that next to last column, it's a 2 minus. So I know I'm going to need 2 manganeses, Mn2, and I'm going to need 3 oxygens, O3. Okay, and last, we're going to have something called polyatomic ions. Poly means many, atomic pertaining to atoms, and an ion is something that has gained or lost electrons. All of these have gained electrons. You have to memorize these. So if you want to memorize them, I would write nitrate, and then I'd write NO3, 1 minus, and then I'd write that again, nitrate, and I'd write it again, NO3, 1 minus. I'd do that 10 times and then see if I could look away and do it. Sulfate, SO4, 2 minus. So sulfate is big S, big O, subscripted 4, superscripted 2 minus. So little 4 down low, a little 2 up high. And that's sulfate. Phosphate is P, big O, a little 4 down low, and a little 3 up high. And that means 1 phosphorus, 4 oxygens, they have a charge of 3 minus. So polyatomic ions, they all stay as one unit. So the 1 nitrogen and the 3 oxygens all stick together. So I'm not going to divide these, and I treat them as one thing. So when I name compounds, I just name the whole thing as nitrate, sulfate, phosphate. So let's see them in some names. I have sodium sulfate. Well, sodium off the periodic table is Na. It's a 1 plus charge. Sulfate is SO4. It's a 2 minus charge. So I know, since this is a 2 minus, I'm going to need 2 sodiums. And since this is a sulfate, this is a 1 plus, I'm just going to need 1 sulfate. If you didn't understand that, this is a 2 minus, so I need 1 of these. This is a 1 plus, so I need 1 of these. So Na2, 2 sodiums, SO4, 1 sulfate. Magnesium is Mg, has a 2 plus charge. Nitrate is NO3, has a 1 minus charge. Okay, so this is a 1 minus, so I'm going to need just 1 magnesium. This 2 over here means I'm going to need 2 nitrates. So I write NO3. I put the whole thing in parentheses and a 2 afterwards, and that means 2 of these things. So I have 1 magnesium and 2 of these things, so I swap the charges again. And it works because this Mg is a 2 plus, and each of these nitrates is a 1 minus, and I have 2 of them. So 2 minus on this side, 2 plus on this side. Chromium 2. Chromium is Cr. 2 means that chromium has a 2 plus charge. Phosphate we've memorized, right? PO4, 3 minus. So that means I'm going to need 3 chromiums, and I'm going to need 2 phosphates. So Cr3, PO4, put the whole thing in parentheses, and put a 2, that means 2 phosphates. Last guy, manganese 4 sulfate. Manganese is Mn. 4 means it has a 4 plus charge. Sulfate we memorize, SO4 with a 2 minus charge. So I know, looking at swapping the charges, I would need 2 of these and 4 of these, but then I'm going to show you something. Mn2, SO4, 4. This is the only time the swapping doesn't work. There's a better ratio than 2 to 4. So for every 2 of these, there's 4 of these. I can also say for every 1 of these, there's 2 of these. I just divided both sides by 2. So Mn, SO4, 2. And it works because this side, 1 manganese is a 4 plus, 2 sulfates, each one's a 2 minus, that's a 4 minus. Okay, and I think that's it on writing the formulas. You just need to practice and make sure you memorize your polyatomic ions, nitrate, sulfate, and phosphate.